fun. All right. Okay, so chapter 1 is introducing us to some basic terminology so that we're all talking on the same ideas, because some of the terminology, when you look at everyday language, gets used in slightly different ways. And it also introduces the primary theory that the book is based in. All right, so we're going to be looking at the introduction to constraints theory, and that should be ringing a bell from the other day, because what's coming up regarding constraints theory? Paper. All right. So this is the start of looking at that information that you're going to need to use to write your first paper. Okay? All right, so the class is called motor behavior. Motor behavior is actually an umbrella term, and underneath motor behavior we have 3 separate areas of study, and they overlap and intertwine, but they have very distinct characteristics. So most of the semester we're going to be concentrating on motor development, because as teachers and coaches and trainers, you need to have an idea of what's going on, why skills look the way they look, how do they develop across the lifespan. So motor development investigates change in movement behavior, and the things that we have to bear in mind when we're looking at this idea is that change is continuous. We don't get to 21 and all of a sudden our motor skills are set in place and nothing else changes for the rest of our life. All right? We used to only study people up to their late teens, early 20s and just kind of assume that skills stay the same. But clearly, when you look at your grandparents or when you look at elderly people around town, they don't move the same way we do. Right? So motor skills change all the time. Changes in motor skills are age-related, but not necessarily age-dependent. So in lab earlier, we were talking about stages of throwing or running, and we expect someone of a certain age to be working at a certain level, but they might not. Right? Physiologically, they may be ready to work at a certain level, but they may not have the experience necessary to show that movement. All right? So changes in movement behavior, what we see, what we observe people do, is age-related. A 3-month-old doesn't run, period. That's clearly age-related, right? But when I'm looking at a 10-year-old, their throwing isn't age-dependent, it's age-related. Make sense? And it's sequential. So we've already looked at the fact that we have sequences within that skill, right? Stage 1, stage 2, stage 3, stage 4. There's a sequence we expect to see as the skill develops. We're also going to look at the fact that skills from walking to running to hopping to skipping have a sequence as well. Right? So we've got various different versions of sequences, both within the skill itself and between skills. And the behaviors that we see, the changes that we observe, depend upon some underlying processes that we want to understand and study and look at. All right, so if we were defining motor development, we'd be trying to combine all those. It's continuous, age-related. changes in functional capacity, and we want to examine the underlying processes that interact with those changes. Right? What's causing the change? So the other two areas of study under the umbrella are motor learning and motor control. And we will, at the end of the semester, we'll have a couple of lectures that look at some motor learning principles. And then we have a 400 level class that you can take as an elective or one of your theory, HPE theory classes, depending which degree plan you're on, more about motor learning. And motor control is an area that becomes a little more complicated, and we don't have, unfortunately, in my view, we don't have the time really to fit in a purely motor control class. So that's a shame, because it's fascinating information, but we just don't have the wiggle room within our degree plan. Motor learning is studying the change in behavior, so not looking at the continuum in the way that we do in development, but a relatively permanent change that I can instill and see within a pretty short period of time. So we're not looking across the lifespan when we're talking about motor learning. We're talking about, I'm introducing a new way of timing your swing to hit a baseball or a softball, right? And within a hopefully relatively short period of time, several weeks or a month or so, I would expect to see some change in that skill. That's motor learning, right? So a slightly different perspective. And motor learning, the changes in behavior that we see when we're coming from a motor learning perspective are based upon experience and practice. Motor control is looking at the nervous system's control of the motor skill. So it's very, very involved with looking at what the brain is doing, what part of the brain is talking at what time, how does it interact with the motor cortex, when and how does the motor cortex initiate signals down to the muscle system. So very fascinating, but pretty highbrow, complicated stuff. So a lot of fun, okay, but takes time, and we don't have the time to get there. On page 12 of your book, within this chapter, you have, there's a little box there which gives you, they call it a litmus test, gives you an idea of how to tell whether the question you're asking, so as a teacher or a coach, when you're teaching motor skills, you often have questions about what's happening in your gym or on your field, or why am I seeing a particular behavior when I was asking for something completely different? At least I thought I was asking for something completely different, right? And yet this is what I'm seeing. So we always have questions come up when we're teaching movement skills. And this little box gives you a way of making the decision. Is the question I'm asking based in motor development, or is the question I'm asking based in motor learning? Is it a short-term learning issue, or is it a long-term development question? All right? So that gives you a way of deciding that. And I think that that's a helpful thing to be able to do, because, you know, one semester of any subject is not enough to learn that subject, period, right? Period. We don't learn anything one time. So that means that when I'm teaching, I'm going to have to be able to go back and look at some resources in order to answer the question I had. Well, am I going to waste a week looking through motor learning resources trying to answer this question so I can teach this person, when I'm looking in the wrong place because actually it was a developmental question, right? So you need to be able to identify where your question lies, really. Some related terms, so terminology stuff, physical growth, you often will see the terms growth and development linked together. There's lots of textbooks. There's lots of textbooks that are titled growth and development, all right? So they're often chucked together there. You've got to just be wary about what physical growth really means. It's a quantitative increase in cell mass, all right? So I am adding cells. It's a quantitative increase in size or body mass, all right? And growth occurs until the system has finished growing. Now, if I go to the gym, right, as an adult, if I go to the gym and I do the right kind of training program and I eat the right kind of food and I get tons of sleep, do I expect to grow bigger muscles? Yes, right. Except, there's the key. That is not growth. That is hypertrophy. I added cells to a system that had finished growing. Okay? So that's one of those times where sometimes in layman's language, we use the word incorrectly. Right? So when I grow, when I do a growth program in the gym, that's not growing, that's hypertrophy. Right? My muscles stopped growing. If I'm doing it as an adult, my muscles stopped growing somewhere around between 16 and 21, 22, depending on whether you're male or female and your genetics, right? So I'm not growing now, I'm adding size and I'm adding mass by a different mechanism, okay? Maturation is the qualitative improvement in a system, so the skeletal system or the digestive system or the sex system, right? Which system, which biological system, they don't all mature at the same time. Each system has its own timeline, okay? So we're looking at a qualitative improvement in functioning within a system to the point where it's fully mature and adult. Aging always seems a little odd to me that they include aging, but what they're trying to put across in the book is that aging isn't old, right? Aging is anything that happens when the system starts to deteriorate.
Like oxidization?
It could be. Due to oxidization, you might see an early aging in a particular system. Yes. Okay. So physiological changes within the system regardless of chronological age. So you might have someone who indicates, particularly if they were an athlete when they were young, who indicates aging in the knee joint because they're showing osteoarthritis and other changes in the knee joint, even though they're only 35 or 40, that's not to do with, because at 35 and 40 I shouldn't see those changes in the knee joint, right? It's not chronological, it's to do with other things that were going on in the system, okay? So historically, in motor development, we have spent a lot of time examining, and PE, we've spent a lot of time examining children and youth and teenagers, all right? But what we look at now, from really the early 80s, we started to look at a bigger picture and try to look more across the lifespan, all right? The percentage of older people in the population is on the increase right across the planet. It really doesn't matter which country you're looking at, give or take a couple. The percentage of the older population is increasing. And yet we weren't studying that population, so we don't know what to expect. We don't know what we can and can't do. We don't know what's appropriate for that population. So how do we keep them healthy if we don't know what's appropriate for them to be doing? Or what should we expect to see? What's typical as we get older? Right? So nowadays, there's a lot more research right across the continuum from infants all the way up to people who are elderly. Okay? Over the course of your degree, and probably the first couple of years of being out at work, you're going to make a decision to probably work with one part of the population, one particular age group. You might choose elementary, or you might choose adults, or you might choose, I like preschool and toddlers, right? Everybody kind of has their favorite age group. If you're a PE teacher, are you going to teach middle school, high school, or elementary? If you're a personal trainer, are you going to work with young adults or older adults? Right? If you're a coach, are you going to work with a little league or an adult competitive team? Right? So you're going to kind of fall into a particular range that becomes your preference. But just bear in mind that the information is out there right across the lifespan, because what you see might be based on something that happened before you interacted with that individual. Because what happens earlier could be impacting what happens later on. So, ta-da! Here's your first look. Hopefully your second look, because you looked at the book before you came, right? So your second look at the triangle. Okay. So this is Carl Newell's model of constraints. He published this model 1986, and it is based upon some other modeling that is horribly complicated surrounding dynamical systems. And so the idea of the triangle and the constraints comes from some other places, and it was adapted for people. So sometimes when you see the model of constraints, this may say organism, for example, because biologists used a similar model before Carl Newell looked at it and went, man, that would be really useful for movement people, right? So we're not looking at organisms because we're particularly looking at humans. So he changed his model to individual, right? So his theory, we have a whole theory that supports the model. The theory examines change, all right? From a developmental perspective, change in movement. And so he said that what we've got to consider is the individual, the who, right? Who am I working with? The what am I asking them to do, the task, and the where am I asking them to do it, right? Environment. So what we get then is, oh, put it out there already. All right. So we have these three different types of constraints. We'll come back to that word in a minute. And what he was trying to put forwards in the model, the reason we have these circular arrows on the triangle here, is that what we find is things that are occurring under each of these categories interact with each other, and they impact the movement behavior that I get to observe. All right? So this movement that I get to see arises because all these things are interacting in a particular way on a particular day. Does that make sense? So we're going to take that idea and look at each of these a little more closely so that they make a bit more sense. But we're emphasizing the interaction between the different types of constraints. So, the word constraint, again, doesn't mean what it means when we use it in everyday language, when we're looking at it in motor development, because a constraint in everyday language tends to be interpreted as a restraint, right? I'm being constrained. In motor development, a constraint might limit a particular movement, but it also, if it limits one type of movement, then chances are it's encouraging a different kind of movement, right? And so the constraints will work together and interact to kind of channel an individual or a particular movement pattern away from one type of pattern and towards another type of pattern that's going to more easily emerge. Right? So for example, if it snows, okay, we were meant to get a ton of snow this winter, weren't we? What happened to the snow? I was so looking forward to that, and next week it's going to be 60 degrees already. Anyway, so if it snows, and you go to Walmart, and there's tons of snow all over the car park because they haven't got the shovels out yet and shoveled it away. Right? And you watch people get out of their car and walk into the shop. How are they going to be walking? What will they look like compared to if you went and parked up in the car park on a nice sunny warm day and the pavement was nice and dry and not slick? So by changing the environment in that case, by adding snow, we see a different kind of movement emerge, because when it's snowy, I'm going to be a little more careful how I walk so that I don't slip. Right? Because even if I don't want to fall over, even if I've got good enough balance and I'm strong enough and I'm young and I'm not going to fall, you know those injuries occur at the damnedest silliest times, don't they? You slip and you jar your back, and then for the rest of the week, every time you go to lift in the gym, your back twinges a little bit. Right? So we don't walk the same way when there's snow on the ground that we do when the ground is dry. The older you get, the bigger the change gets, because there's an interaction with the individual as well as with the environment. Doesn't have to be a negative. Constraints can be positive. Right? I could decide, right, I like to snowshoe. Well, I can't snowshoe when it's dry. I have to have snow on the ground. So snow permits me to use a completely different movement pattern that I like doing. Right? So it's not always a negative, it can be a positive. Don't get into the habit of thinking that a constraint is always negative. So what are they? These 3 points on the triangle, what do they really mean? All right? The top point on the triangle is to do with the individual, the person that you are working with or yourself. Okay? So individual constraints are unique, physical, or mental characteristics for the person. All right? They're internal to that individual. They might be genetic, they might be emotional, right? All kinds of things going on with the person that might change what you see on a particular day. And we split, if you go back and look at the triangle, right? We subdivide them here into structural and functional. So structural individual constraints are literally that. Anything to do with the body, with the actual building of the body. So someone's height is a structural constraint. Someone's muscle mass is a structural constraint. They got big feet or little feet, that's a structural constraint. Right? The reason, hold on, let me finish. Functional is behavioral. So how they're feeling on a particular day. What are they thinking about? What's bothering them? And it's important to distinguish those because on any given day I can't really affect someone's structure. Right? In order to change a structural constraint takes time. And depending upon the particular constraint and the age of the person you're working with, you may not be able to change it at all, right? Because if it's height and you're working with adults, that ain't changing, so you can't do anything with that. So changing a structural constraint can be done in certain circumstances, but it takes time to do it. So in my particular PE class today, or in my training session today with my athletes, I'm not doing anything about this that's going to impact their movement today. Make sense? Right? Functional could be motivation, could be attention, could be fear, could be I'm feeling sad, could be I'm absolutely blasting mad because I had an argument with my husband before I came to the gym today, right? Anything to do with how I'm feeling inside, in my head, here. So, if you're clever as a teacher, and if the person is being receptive, right, then I've got the opportunity for some more immediate change there, possibly, right? My athlete may come to the training really tired because they didn't sleep very well, and if they're tired, then their motivation for training might be, right? What can I do with training today? Because I've got two options. I can go the hell away because you're wasting your time today, right? Or I can go, all right, let's get motivated. What am I going to do to get you motivated? Come on, what's it going to take? And maybe I can do something that gets them motivated that makes that training session worthwhile. Because we don't want to waste a training session, they're precious, right? So sending them home is not my first option most of the time. But training not motivated is a waste of time. Nothing good is going to come out of that. And maybe something worse than not good is going to come out of that because they get hurt. So what am I going to do to change that on that day? Because it might be different to what I have to do tomorrow. Maybe I can manipulate what I'm asking them to do, the what or the where. And just by manipulating the what or the where, I increase their motivation. That's what makes good teachers. So the environmental constraints, the where. What's involved in the environmental constraints? Properties of the environment. So we're external to the person. This has nothing directly to do with the individual. It's the where, everything outside, all right? They're global though, they're not task specific. So it wouldn't matter which what I was asking them to do. The environment constraints would be similar. Right? They can be either physical, so things like gravity. Right? We were born on a planet that has gravitational pull, and that gravity severely impacts our movement patterns. Right? Everything you do would not look like it looks if you weren't doing it on this planet. right? So gravity plays a role in heaps of things, and you may or may not, because we can't change gravity, but I can use gravity and change a skill if I understand how it works in relation to the body well enough, which is why biomechanics is such a fun class to take, because in biomechanics I'm going, all right, what is going on here in relation to gravity? What can I change? How is gravity impacting this body? Okay. It could be the surface. So we talked about the snow in the car park, or a dry surface, or icy, or sand, because we're in New Mexico, dirt, right? Or it could be the wall. It doesn't have to be the floor. If you're a racquetball player, what difference does it make if the racquetball court has been newly smoothed over and painted and is nice and flat, versus if the walls are all bumpy and have great big chunks cut out of them where people have hit them with their rackets, right? So surfaces can be a constraint. Sociocultural constraints are ones we tend to not appreciate immediately because they're quite subtle. But gender roles are a big sociocultural constraint. Right? Up until the 70s, we didn't really encourage women or girls to take part in sport because they've got all those little inside bits that are important for babies, and we don't want to jiggle them around in case something goes wrong, so we've got to wrap them up in cotton wool and keep them at home nice and safe. Right? So, now, thank heavens, we've got like a little further past that, and we're better at encouraging girls to take part in sport. Title IX, when you take your law class, made a big change. But it's not enough. Right? So later in the semester, we're going to talk about gender stereotyping, because it's fascinating what we do, not deliberately, it's totally subconscious. Right? You don't deliberately stop someone from having fun and moving and being healthy, but we do things that do not encourage girls, or we have age roles. So I'm a gymnast. I like going upside down. Sometimes I go upside down just when I feel like it. And sometimes that embarrasses the people that I'm with because they didn't think it was appropriate for me to do a cartwheel in the middle of Walmart. But I was bored in Walmart, so I thought I would do a cartwheel because cartwheels are fun. And everybody goes, oh my God, I don't know her. Right? But if I was 5, and I did a cartwheel in Walmart, would anybody care? Okay? You only care because I'm 50. That's a load of nonsense. Okay? So age roles, gender roles, race roles, right? All kinds of sociocultural constraints that are a lot more subtle than what we see going on here. Right? Okay, the third part of the triangle then, third corner, task constraints, the what. What am I asking them to do? And is that impacting what I see in a good way or a bad way? And if it's not producing what I want, how do I change it to get what I want? Because most of us, when we're teaching a skill, have some idea in our head of what we expect that skill to look like, and or the outcome that we want for that skill. But we don't always get either of those. Okay? So I can get cross about that, but that doesn't help, because it doesn't change anything. If I'm going to be a good teacher or a good coach, I would have to change what I'm asking for and get what I want so that the brain can learn how to do it properly. Because repeating the wrong thing over and over and over again only teaches the brain how to do the wrong thing. If I want it to learn the right thing, I would have to allow it to produce the right thing in order to learn what that feels like. Okay? So, how do I do that? What can I manipulate to help the brain learn and produce the skill? Remember our triangle, right? The behavior that emerges, I want that to look like this. So what am I going to manipulate? So the task constraints are external to the individual, obviously, but they're different from the environment because they're specific to the task that I'm asking for. So they could be something to do with the goal of the task. So the goal may be to put the ball through the basket. Okay. Well, does it matter if I ask for the ball to go clear through the basket, or you can hit the ball off the backboard into the basket? Do I see something different depending upon what I ask for? It could be the rule guiding the what I'm asking them to do. So if I'm playing tennis, the rule is the ball can only bounce once, and then you have to hit it. Right? So if I'm not very good at motor skills, what's the problem with the ball only bouncing once?
You have less time to hit it.
You have less time. What if I can't even get to the ball when it only bounces once? Right? If I'm trying to teach you a forehand, but you never hit the ball because you can't get to the ball because it's only allowed to bounce once, then you're probably not going to learn how to do a forehand. Right? Because I would have to practice the forehand. So I can just change the rule. My PE class, I can do what the heck I like. I'm in charge. Right? Now the rule is the ball can bounce up to 3 times before you hit it. Now what happens to the people who weren't able to hit the ball?
There's a greater accessibility.
Greater accessibility. Maybe they can get to the ball. Maybe they get to practice a forehand. If they practice the forehand, we assume most of the time correctly that practice improves performance. Improved performance makes it more what? What were we talking about earlier? Enjoyable. It's fun. And if it's fun, I come back and do it again. And then I get better at it. Or I pay you more money if you're a personal trainer. Right? Think about that. Your whole income relies on them coming back. If they're not having a good time, you ain't paying your mortgage this month, my friend. That's not a very good way to go. Alright? So, right? What's the rule? Can I change the rule? Right? If I'm in a competitive sports situation, no, I can't change the rule. Right? But if I am teaching someone to get to a competitive sports situation, can I change the rules so that they can practice and enjoy and achieve the skill well enough in order to compete the skill? Sometimes when we're teaching and we're coaching, we get very rigid about the rule is, change the damn rule. Who the hell cares? Change it. Make it fun for the people you are working with. And then put it back to what it's supposed to be once they've learned the skill. Right?
Sequential.
Sequential. Or divide your class up into 2. On this tennis court, the rule is 1 bounce. So, if you want to play competitive tennis, you can come and play on this court. On this court, the rule is 2 bounces. So if you don't want to play over there, you can come and play over here. Okay? Equipment is a task constraint. So what kind of equipment am I providing? All right? Or what kind of equipment do they have? Do they have proper running shoes, or do they only have flip-flops? If they only have flip-flops, the biomechanical data clearly shows they do not walk, run, jump the same way they do when they have running shoes on. So, if you have a child whose parents have not either thought about buying them running shoes or have the money to buy them running shoes and they only have cheap flip-flops, you're not going to get the behavior you want. What about what size racket I give them? Let's stick with our tennis. Do I give them Sharapova's racket? Anybody watching the Australian Open this week? Australian Open started. Oh, very fun. Oh my God, the women's draw has gone kaplowy. Everybody's getting knocked out. Sharapova's racket head is about this big, I swear. If I picked her racket up, it's massive. Right? So if I give that racket to someone who's not very good or isn't very strong, are they going to be able to use that racket to hit a tennis shot? I might see some really weird types of behaviors that aren't really what I want them to be practicing. So can I provide a different racket? Can I provide a racket that doesn't weigh so much? Or that has a shorter handle so that it's easier for them to manipulate the head of the racket. Right? What can I do? If we're playing basketball with 7-year-olds, what are you going to do? Are you going to take them down in the gym and tell them they have to shoot at that net down in the gym, basket, whatever it's called? What are you going to do? Right? If you take them down in the gym, are they going to be successful? Probably not, because 7-year-olds aren't Ruby. So what can you do as the teacher to change these constraints so that the movement emerges, the movement that you get to see is more like what you want, because then the brain will be practicing what you want it to practice.
So you adapt to certain conditions to get to a specific task.
Yes. Yeah. Right? Now, sometimes, because you're experienced in sport, you might be sitting there going, well, duh, of course. Right? But you'd be amazed how that does not happen when you're working with people who aren't good in sport. Right? What happens in dodgeball? I hate, by the way, just warn you now, I'm going to be dissing dodgeball all semester. It is the worst invention ever. Ever. It's worse than McDonald's. And that's going somewhere.
Wait, why do you hate it so much?
Okay, what happens if you're playing dodgeball? This is why I hate dodgeball, right? If we're playing dodgeball by the rules, what happens in dodgeball? Yeah, in the face anger. What happens when you get hit? You're out. Okay. So, and you get hurt, which, by the way, is not fun. In my book. Some of you might like that. My husband he comes home and he goes, oh, I got hit with the racquetball. My partner went pow, and it bounced off the wall and smacked it. And I'm like, is that, you sound like you enjoyed that, you crazy person. Right? So, you get hurt and you sit out. Right? Is that right? Those are the rules. You try to hurt someone as much as you can, and when they're hurt, you make them sit down. Yes? All right. Who gets hit first?
Last
Or
one.
slower and.
The people who are slow,
Was it?
who can't jump, who aren't agile, who may be overweight. Right. Are they the people you want sitting down? Let me see. We're trying to make people healthy and skillful, but the fat, slow people are sitting down.
It's like an ego
But
test.
that's where they learn to develop some motor skills.
Right, right? That's why I don't like dodgeball. Okay? Now, so can I change dodgeball? Okay? Could I use a softer ball? Or can we rotate people in and
No,
out?
I said just make them run laps.
Make them run laps. Oh my God. All right, no. Okay, next tale. Do not use movement as a punishment. Never, ever, ever, ever. I don't care what your coaches do. They are wrong. Never, ever, ever use running and press-ups and conditioning as punishment. Moving is supposed to be fun. Fun!
It's like false conditioning.
Yes! Right? Oh, we do horrible things in PE and coaching, right? We break all the rules. It's horrible, right? So, dodgeball, if you're competitive, right? Most of you probably love dodgeball because you are, personally, your makeup is competitive. Not everybody is competitive, right? They're not. If you're not competitive, and if you're not skilled, you guys are all highly skilled. So of course dodgeball's fun, because you can throw well, you can dodge, you can jump, you can run, you can catch, right? Of course it's fun. You get a great workout. It's heaps of fun. But you are really, really good. Okay? So remember I said, this semester is going to challenge a lot of how you feel because you are not typical. You are unusual people. So you're going to have to spend a lot of this semester stepping outside how you feel and thinking about a slightly bigger picture for people who aren't as talented as you are. Because when you teach, you don't get to teach just you. You get to teach all kinds of people, some of whom can barely walk, let alone run or catch or throw. All right. I wanted to show you that, but we're kind of, is it 10 to? Or have I got 2 minutes?
Or 49.
Okay, we'll watch that